The second page of the notes is really just talking about what a complex number is and how you can simplify or add and subtract, multiply with complex numbers. It says a complex number written in standard form is a number that's in the form a plus bi, where a and b are real numbers. The number a is considered the real part of the problem, and the bi is considered the imaginary part. It's a complex number because it's made up of both parts. If you look down here in the key concept box, there are two rules for the sum and differences of complex numbers. You really have to just kind of think about them as you're combining like terms. If you're trying to add two complex numbers together, you can add the real parts together, and you can add the imaginary parts together, and subtraction is the same way. So if you look down here, for example 1, I have 8 minus I, just like 8 minus 1i, plus 5 plus 4i. You really just have to think about this as combining like terms. You can combine the real parts. 8 plus 5 gives you 13. Negative 1i plus 4i would give you 3i. And that is your final answer. Real numbers and imaginary numbers are not like terms, so you cannot combine them. And typically you will see these written as the real part of the problem is written first, then the imaginary part. Subtraction is really no different. You would just subtract your like terms. 7 minus 3 is going to give you 4. Negative 6i minus negative 6i, well, that's the same thing as negative 6i plus 6i, is going to go to 0. You can write 4 plus 0i, but whenever you don't have, that means you don't have an imaginary part. The best answer would just be 4. This is another example of really how you're just combining like terms. One thing you need to think about too is this, on a problem like this, you may want to think about distributing the subtraction throughout the parentheses first so you can really see the signs on your like terms. For example, this problem would be best if you rewrote it first as 10 minus 6 and minus 7i plus 4i. And then you can really see the correct signs and combine your like terms. 10 minus 6 will go to 4. Negative 7i plus 4i will go to minus 3i. Now, you can also do multiplication with imaginary units, and you're really just going to go through. And this is where, if you remember from the first page, how when we said that I, by definition, was equal to the square root of negative 1, that also I squared has a value of negative 1. And when you start to multiply, this is where this comes into play. After you've completed the multiplication, what you need to look for is if you have an I squared in the problem, you need to take that out and replace it with a negative 1. So for example, on this problem, this really would just be the distributive property. I'm going to do I times 9, which will give me 9i. I times negative I is negative I squared. Now if those had been x's, we would have been done. But the thing is I squared, I know, is the same thing as negative 1. And so really what I have is 9i minus negative 1, or 1 plus 9i. Number 5, the same thing. This would be a problem where we distribute twice or use the FOIL method. 3 times 5 would give us 15. 3 times negative I is negative 3i. I times 5 gives us positive 5i. And I times negative I gives us minus I squared. Well, the first thing we can do is we can combine our like terms that we have right now. Negative 3i plus 5i goes to positive 2i. And I squared has a value of negative 1, so that changes the end of this to minus a negative 1, which we can then change to plus. That means you also have another set of like terms, and your final answer would be 16 plus 2i. Now, if you have a problem like number 6, where you have an I in the denominator, this is the same thing as having a square root in the denominator. You would have to rationalize it. So for example, on this problem, because we have a 2i in the bottom, to get rid of that or to rationalize it, we are going to multiply the top and bottom by 2i. And then again, we just multiply straight across. That will get us 10i over 4i squared. But again, I squared is equal to negative 1, so really we have 10i over negative 4. And then yes, you can reduce the 10 and the negative 4 down to negative 5 over 2 I.